I'm Nick Horton from Amherst College. It's been a long time since I took the SAT, a standardized test used for college admission in the United States. The SAT math test is described, as you see here, as something that covers a range of practices with an emphasis on problem solving, modeling, using tools strategically, and using algebraic structure. I was curious to see how much statistics is now included on the SAT. So I decided to explore some of the sample questions that the College Board has made available. So they have 30 questions online. There's a kind of a background here that gives a sense of which ones allow a calculator, which ones don't. When we jump into the first question, it's an inequality question that's important mathematics, but not as much what I'm interested in. And we look at the next one, which is actually a neat problem. It's actually talking about how we actually think about margin of error, replications, and the like. So it's looking at a survey of undergraduate students, and it asks questions about which will likely result in a smaller margin of error. That's kind of neat. Question 3 is one of 3 questions that are related using the same scatter plot. We have a scatter plot of height as a function of the length of the first metacarpal bone. Again, very nice structure in terms of the units being put there. And it asks the question, how many of the 9 people have an actual height that differs by more than 3 centimeters from the predicted height from this line of best fit? So here we have a regression diagnostic, residual question asking about interpretation of this. This problem continues with 2 other problems. This one asks a best interpretation of the slope of the line of best fit. And the third part with this related, all using the same figure, is based on the line of best fit. What's the predicted height for someone with a first metacarpal bone with a length of 4.45 centimeters? If we continue on through these other questions, there's one that's not marked as data analysis, but is an equation of a line. Talking about a hotel, there's both fixed costs and costs that scale with the length of the visit. Moving on to question 7, it's a much more of a passport to advanced math is how they describe that. Question 8 is the first of an example of cross-classification tables where we have things divided as to whether or not they're solid, liquid, and gas, along with the marginal totals. And so the question is to ask what fraction of all solids are metalloids. So it's kind of thinking about those 2 relationships of things. We have a kind of more standard heart of algebra problem. And then 2 related, both questions 10 and 11, relate to this cross-classification table. For which age group did the greatest percentage of people report that they had voted? Question 11 asks the same thing of this. Of those who reported voting, so some conditional probability type statements, and to kind of think about what the interpretation would be in the actual population this is coming from. Question 12 is really focused on an inequality. Question 13 actually gives us kind of a neat question. If the mean age of the males is 15 and the mean age of the females is 19, what does that tell us about the overall mean? So it's thinking about kind of properties of these summary statistics and subgroups. We have a design question about association between sleep and exercise that was found amongst a random sample in the US. What does that let us conclude? Again, we can really conclude there's a positive association, but it doesn't really tell us possible confounders. So really not hearkening to the kind of multivariate thinking that the Gaze report is encouraging people to do, certainly in the college statistics course. Number 15, kind of thinking about some exponential growth. 16, another one of the kind of additional topics in math. 17, kind of thinking about gas mileage problems. Again, important math literacy kinds of things in here. Toll rates and trying to understand how those relate. This is really the heart of algebra, is the flag on it. Then we have question 19 is really thinking about another one of these linear equations. Number 20 is a slope problem. So we have this scatter plot of manatees year and the number of manatees. Good news is the manatee population seems to be rebounding to some extent, and so students have to interpret that slope. Actually, a fairly cool problem here of a nonlinear relationships, and it's important to remember that many of the states have curricula for the high school that do include modeling both in a linear and nonlinear way. And so here, kind of interpreting that model kind of comes, again, typically not something we do in IntroStat, but again, it's something that's many students are actually building upon. If we continue going through the other questions, you can actually see that most of these end up being more math-like, but a considerable chunk of these earlier ones really were ones that I would think of as material that we've traditionally taught in the IntroStat course. And to me, this has been raising really interesting questions about how we can be thinking and building upon that framework. Again, found some interesting things here. Would encourage you to explore as well, and happy spelunking.